Did you know that aquarium plants can grow perfectly fine and even thrive without any substrate? That's right. Substrate is optional when it comes to aquarium plants. And in this video, I'm going to tell you exactly why. You see, I'm the first person in history on the planet to send my regular home aquarium waste from tanks just like this one off to a professional soil and wastewater analysis lab to have my gunk and debris from these nanofish and snails and shrimp. I had it tested for its nutrient value. And what I found is actually shocking. So we're going to talk about that in the video today. We're going to be taking a look at not one, but two no substrate, bare bottom planted aquariums that just use aquarium waste, the gunk, the debris. Some people call it liquid gold, even though it's a solid. And commonly, most aquarists remove this gunk at the bottom of this aquarium and replace it with liquid fertilizer. Now, you'll see a bunch of stuff floating around in this aquarium. I just fed Rapashi, and I did that to bring some of the livestock out. What we've got in here is a mixture of a couple different kinds of nanofish, but mostly we've got juvenile small Amano shrimp. That's right. All those red shrimp in there, those aren't Neocaridina. Those are Amano shrimp. So, I didn't plan it out to be this way, but on top of being the first guy to send my detritus or mulm, that fluffy brown stuff at the bottom of this aquarium, on top of being the first guy to think of the idea of having it actually professionally tested for its fertilizer values, I'm also currently the only dude breeding Amano shrimp on YouTube using super low-tech methods, especially when it comes to raising the Amano shrimp larva in saltwater. I've got a playlist for that on my channel, where between this channel and one of my other channels, I take you 100% through the process of breeding Amano shrimp. And believe it or not, compared to how many are usually in this tank, this is not even a lot of Amano shrimp. I usually have about 3 times this much. So in here are some wild type Amano shrimp. I've got some of the snow white Amano shrimp, and of course these sun orange Amano shrimp that I'm selectively breeding to get as much of that red coloration that you see out of them. And it seems to be going fairly well. So let's take a quick tour of this tank, and then I'm going to get down to explaining exactly what I mean when I say that substrate's optional. Your plants don't really even need it in an aquarium. And the results of my lab testing of this gunk and debris will probably change the way that you think about growing plants in your aquarium. So what we've got here is a 40-gallon, and you'll see here some glowing eyes on these rice fish. I think there's just 4 young rice fish in here. They're also babies. And my favorites currently are these Stiphodon Gobies. And I'm sure you're probably thinking what I'm thinking, which is, hey, if you're breeding Amano shrimp and raising the babies in saltwater, are you going to try to breed those Stiphodon Gobies? Is that why you have Stiphodon Gobies? Are you going to try to be the first guy to do that too? So yeah, nobody has bred Stiphodon Gobies, and of the people that have claimed to, nobody has documented it. So I'm going to try to be the first guy on that as well. And as you see here in this 4K 60 frames per second live stream, I'll be doing it in the highest quality possible for you guys and gals, so that if I have success, you can replicate my success, and if I have failures, you can avoid some of the pitfalls of doing what I'm doing. But so there's a ton of debris in this aquarium. I mean, it's no secret. It's right out in the open because there's no substrate. So let's take a quick tour and then we're going to get into the nitty gritty here. The first thing you'll notice way over here on the left is I've got what Petco calls an aquarium plant cage. I call it a moss dome because it's designed to grow moss out of. And I like stuffing pearlweed in there. I think it's kind of a cool way to grow pearlweed. But that is the Imagitarium plant cage. It's basically a moss dome. Pretty cool stuff. I've got a sponge filter there that's not hooked up to anything, that just has a stem plant shoved down in the tube. And we've got some Imagitarium black lava stone. This is a black lava rock that you can get at Petco or from your local pet store, most likely. I've got several pieces of that in there. I used to have also the red lava stone, but I found that the red lava stone, probably the black lava stone does it too. I just don't see it because the bottom underside of this aquarium's painted black. That's why you're not seeing a bunch of reflection on this bare bottom aquarium, is because the underside on the outside of the aquarium is painted black, just like you would do with a background. And so for me, that makes it really cool because it adds a element of pop to these colorful Amano shrimp. That's why the red ones are sticking out so much like they are. But so the black lava stone and red lava stone, you'll get little crumbs, almost like a lava rock dust. And the red lava stone was pretty visible on the bottom of the aquarium. And, you know, I do remove detritus from this aquarium ever so often, and we'll talk about that a little later. But when you're going to remove the aquarium waste, the little dust from these lava rocks is pretty heavy. So it would leave, you know, heavy red crumbs on the bottom of the aquarium that wouldn't always easily siphon out. So I got rid of the red ones. Now, if we scooch over here, little to the side, you'll see a couple aquascaping resin stones. I believe these are from F Zone off of Amazon. And it's kind of hard to see them back there, but there's 3 of them. And these F Zone aquascaping stones are a resin mold, and it gives them a real nice triangular shape, and you can arrange the 3 of them, you know, for your viewing pleasures. And tucked in between the big one and the medium sized one is another one of those moss domes. So you can see how the perspective of growing plants in a no substrate aquarium like this can change based on what you do with the plants. We're going to get into that as well. So moving right along here, I've got an Imagitarium zebra stone here. We're going to skip over this third stone to the left. We'll talk about that one in just a second. But here on the right, you see 2 zebra stones from Imagitarium, and it's kind of hard to tell because of the coating of algae on them. They've been in here for quite some time, but they have like zebra stripes on them. They're pretty cool looking stones. The main difference between something like the zebra stones and the lava rock is the lava rock's very, very light. So if you drop a lava rock in a no substrate aquarium, you're probably good. These are very heavy in comparison, so you got to be careful with them. Getting them in and out of your aquarium, they're probably more likely to scratch the glass just because they've got so much more weight to them. I don't know. But great stone from Imagitarium. And then to the left there, the third stone to the left that's got the nice coating of algae on it is a Penplax. And this is one of the set it and forget it type of rocks you can get for your aquarium, where it's like preloaded with plant seeds. And so this is the Penplax Aquaflora's Rock Range Aquarium Ornament. Now, when I first got it, it did grow some plants. I can't remember the name of them, but they're the same kind of plants that you commonly would get on Amazon as seeds. They grow for a while and eventually they die off. I've had this for a long time now, and it did what it said it was going to do. It grew plants. I didn't have to do anything with it. You just set it at the bottom of the aquarium. And at this point, it's growing more algae on it than anything else, which is perfect for the shrimp and the gobies. So it works out great. Then all the way to the right here, we'll see that we've got some more of the pearlweed that's growing in one of these plant domes, the Imaginarium plant cage. Pretty easy to do. And if you want to stuff Wassertang in there, believe it or not, Wassertang grows great out of the little plastic mesh netting there. And then as far as livestock, we talked about that. We've got the rice fish and just a ton of these baby Amano shrimp in here. And this is, this is not a lot of Amano shrimp compared to how many juveniles I typically have growing out in here. This is about a third of what it usually looks like. So between them and the snails, you can really see just how much debris they create. And before we start getting too deep into it, I just want you to think about that. I want you to think about the fact that no matter what kind of substrate you have, whether it's gravel or sand or aqua soil, your livestock is producing this stuff constantly, 24/7, right? And so as aquarists, we're told from the very beginning to remove this stuff. And the way that it gets talked about in the aquarium hobby is pretty strange once you know what's physically in your aquarium waste. And so we're going to deep dive into that in this live stream. So buckle up and prepare yourself for quite the adventure. So first things first, I want to talk about how exactly I got here to this point where I'm sending samples of my gunk and debris from my aquariums off to professional soil and wastewater analysis labs. I mean, this is a lab that tests soil for farming and stuff like that. And they had never had someone like me contact them before. They thought it was very interesting. And the test was very professional. They test it in its wet form and then they dry it out and test it in its dry form. And so it's really a thorough test. And I was pretty shocked that I'm the first person in human history to think of this, because planted aquariums are not anything that's new. And there's a whole lot of things that get said about the gunk in the bottom of our aquariums. And we're going to talk about some of the most common things you'll hear and how that applies to the reality of what this waste actually is. So these shrimp are swimming around like fish. And I put a bunch of, well, not a bunch, but I put some Rapashi in here and they are just tearing it up. I think most of it has been captured by the Amano shrimp and probably carried in the back somewhere. They like to grab it and swim off with it and hide. If you've ever had Amano shrimp, you know exactly what I'm talking about. It's pretty funny actually to see them become little tank bosses. But so how did I get to this point where I'm sending off aquarium waste to get lab tested? Well, I was growing aquarium plants like most aquarists and finding myself with excess plants. And, eventually you get to a point when you're growing aquarium plants that, especially with fast growing plants, you can only have so much of, a particular kind of plant. And you end up wanting to trade or sell some of your excess plants. Maybe you give them away, but you can't keep them all, right? And some people just chunk them. Some people dry them out and feed them back to their fish. But I found myself with a bunch of extra aquarium plants with nowhere to put them. I didn't want to put them in one of my aquariums I wanted to keep them separate because I had a plan for them. I knew someone that was going to trade me some stuff for the plants, and I wanted to kind of keep them off to the side and not have to worry about a bunch of snail eggs getting laid on them or worry about, you know, any issues. Depending on what kind of plants it are, these Amano shrimp will nibble on plants here and there as well. So my plan was to just stick the plants in a quarantine tank that had no substrate in it. And I thought that was the perfect idea because at the time I didn't have any fish in that aquarium. I just had a bunch of snails and there was no substrate, a sponge filter. And so I put the plants in. It was a mixture of some swords and some stem plants and some crypts. And what I realized almost immediately is, well, if I just stick these in there and there's no substrate to hold the plants down, they're all going to float at the top. And there's a bunch of stuff floating in the top here. And if you've ever tried floating aquarium plants, especially like crypts, they start to grow really weird. They start to get gnarled as they twist and turn at the top of your aquarium. The plant wants to grow facing the light. And every time the plant gets moved around, it has to grow a different way to reach the light. And what you end up with, especially with crypts, is a plant that is not fun to try to plant into substrate once you get ready to plant it. There's other plants like this val. You can grow a single big val floating, but once you've got a ton of val, if you try to float them all, you're just going to end up with a bunch of it melting. So there's a bunch of reasons why you would not want to store aquarium plants just jumbled up floating in the top of your aquarium. So I thought about it and I decided, well, I'll just weigh them down with something, right? And one thing I did, I've got a plant here towards the front we can look at as an example. This little bitty Anubias there. That thing you can tell was floating for a while and because of the way that it's growing. But that Anubias there, you can kind of see a little bit of a white cylinder peeking out from under the Anubias. What that is a single piece of biomedia, and I glued the base of the Anubias to the biomedia. Now, this is nothing revolutionary. Anubias is typically glued or tied to hardscape. And we're going to start getting into some of that myth busting, but it's actually pretty hilarious that with Anubias, it's acceptable, commonly known, and never argued that it's not going to be buried in substrate. Now, I want to make this clear. I'm not against substrate. I have plants on the rack above this, on the shelf above this, that have aqua soil in them. I've got tanks, that is. I've got tanks that have gravel in them. I'm not against substrate. But in these particular aquariums, it's much easier for me to not have any substrate because it allows me to not only see how much detritus is built up, but it allows me to manage it, right? A lot easier than with a gravel vacuum. And we'll get into that. So I weigh down my plants using a couple methods. One of them was just to glue the base to a piece of biomedia. And it could be any plant. It could be a stem plant, a sword, a crypt. Just take the base, whether it's a part of the roots or it's the physical base of the stem, just take the bottom of the plant, put a dot of super glue on something that sinks and let it sink to the bottom. Now, another method that I found works pretty good is to take a plant weight and either take a little piece that you cut off and loosely wrap it around the base of the stem, like typically you see done at the pet store, right? To keep usually a bunch of like 3 to 5 plants together when it comes to stem plants. And as long as you're not like, you know, pinching the plant really hard, it typically will do just fine like that. Another method I've used is to cut off a tiny piece of a plant weight and clamp it on one of the roots. And you can be a little more aggressive when you're clamping onto a root, but eventually it's probably going to melt. So where it's clamped, but it'll work for a while. And depending on where you have it situated, if there is a rock next to it, a lot of times before that one single root that you have clamped with the plant weight has a chance to melt, the other roots will grow and attach themselves to whatever they can, even if it's other plants. So it works really well to just weigh plants down in the bottom of the aquarium. This keeps them from growing all gnarled. So what I originally thought was going to be maybe a few days of keeping my excess aquarium plants in this quarantine tank quickly turned into a couple weeks. And then before I knew it, they'd been in there for a couple months. And one day I realized, you know what? These plants are actually growing really well. They're thriving. They're growing as good as they would in any of my other aquariums. So I wonder why that is. We're all taught that any plant that has roots other than, say, Java fern and Anubias, they need to be planted in the substrate, right? And so how is it that these plants are thriving without any substrate? So I started looking into it, and I started getting answers. And all of the answers I got pointed towards plants in aquariums, aquatic plants, water plants, whether it's fully aquatic or amphibious, like a frog bit, you know, the top half grows out of the water, the roots and stuff grow down into the water. No matter what kind of plant it is, they eat differently than land plants. They uptake nutrients differently than land plants. But that's not the way it's explained in the hobby. So we'll talk about that. And I think that'll really open up your mind to why exactly you don't need substrate for your aquarium plants. But so when I realized that it was probably the detritus doing the heavy lifting, I decided, well, let me look into it and see what people are saying about detritus, mulm, gunk, right? Debris. And what I found is, like many things with the hobby, there's a giant echo chamber that all were just kind of copying off each other, and they all say the same thing. A lot of people refer to aquarium waste as excess nitrates, and it's really not true, and we'll get into that. But the important takeaway is that just like it's readily acceptable for a Anubias to grow with no substrate, but there's a knee-jerk reaction for the hobby to say heavy root feeder needs root tabs, put it in the substrate when it comes to, say, an Amazon sword. It's not true. They're not heavy root feeders. They have big roots, but the roots are relative to the size of the plant. So we'll talk about that as well. So when it came to my detritus, I knew there was more to it than just nitrogen. That's what everyone talks about, nitrates, excess nitrates. But they don't ever say how much nitrate is in it because nobody's ever tested it. I'm the first guy, right? Now, what else is in it? It can't just be pure nitrate. There's got to be other stuff in there. Well, nobody knows because nobody thought about sending it to the lab, right? So that's how I got into this. Was I didn't start off looking to disprove needing substrate. I didn't start off looking to disprove needing fertilizer. Both of those things have a place, and there might be times where it's easier to just plant your plants and substrate. There might be times where you need fertilizer. So we're going to get into that as well. But I wanted to kind of give you a little bit of background as to exactly where I'm coming from with this. And I want to also specify that I'm in no way saying that this is the only way or this is how you should grow aquarium plants. You need to rush to take your substrate out because substrate's bad. I'm just simply sharing my experience with you. But more importantly, I'm sharing the hobby's very first testing of home aquarium waste. Straight up, nobody's done it. Until now, the only results of testing of aquarium waste, quote unquote aquarium waste, comes from things like trout farms or salmon farms. And it just simply doesn't apply to our aquariums because in a lot of cases, those studies, first off, they're not testing the waste to see what all it has. In a lot of cases, they're just looking to see how much nitrate's in it. And those are completely different fish than what we have. They're fed a completely different food. They get way more activity and exercise. I mean, it's totally different, right? The detritus that I sent off was from nanofish, dwarf shrimp, and snails. And they were contained in a home aquarium. It's the closest thing that you'll find to a real world example of what's in aquarium waste, because that's literally what I did. Now, another disclaimer here is everyone's detritus or mulm or aquarium waste, gunk, debris, it's going to be different depending on what you feed your livestock and what livestock you have. So I would suggest that before you spend $20 on that next bottle of fertilizer or packet of root tabs, go to Google, find the soil and wastewater analysis lab near you. I guarantee you have probably more than one in whatever state you're in here in the United States. And go to their website and look at how much it is and where to mail the sample to. You might even be able to hand deliver it if it's close enough to you. It's very inexpensive. I was actually shocked at how inexpensive it was. And once you get that waste tested, you'll know what's in it. There's no guessing at that point. It's actually a really smart thing to do, whether you're looking to have a mini aquarium plant farm at your house where you're constantly selling aquarium plants, or maybe you just have a couple of aquarium plants and you just, you're just curious. The only way to know is to get it tested. So we're going to talk about this stuff and it's going to get really good. So it was kind of an accidental discovery. Again, I wasn't looking to disprove myths or, come up with reasons why. I was just trying to figure out what was happening in my own aquariums. So I think it really the easiest way to explain what happens is if you look at what's happening in here. I've got plant weights. I've got some of these plants are just wedged in place. But if you think about it, there's really not a lot of difference between a no substrate or bare bottom aquarium like this and gravel when it comes to what your plants eat, because your plants cannot eat rocks. So if you've got gravel, it's just a way to hold the plants down. There's no food in the gravel. Now there's detritus that settles down into the gravel. And remember, again, no matter what kind of substrate you have, your livestock is producing this stuff 24/7, right? So let's talk about the terrestrial bias when it comes to the aquarium hobby. I think that most of what we think we know about aquarium plants is based on terrestrial plant science. And what is terrestrial plant science, you might ask? It's land plants. And these aquarium plants don't eat the same way as land plants. And I'm going to explain that in the briefest and most simple way that I possibly can, but it's true. Now, first things first, and for you aquarists out there that use dirted aquariums, I'm not trying to just poke holes in it, but what I'm saying is scientific fact here, and that is the dirt that's on land, okay, garden soil, or the dirt in your backyard, that is detritus from land. It's leaves from trees. It's litter, human and plant litter. It's dry land waste. And a lot of times, especially with creators, they like to compare dirt, like garden soil, to what's in the bottom of a pond or a lake. And what's important for you to understand is at the bottom of a pond or a lake is this stuff. Now, ponds and lakes typically will have a clay base. They have to have something to hold the water so that it doesn't just seep through. Now, if we're talking about certain states and sea level, like Florida, for example, if you dig a hole in the ground at certain elevations, it's going to fill up with water. Um, but that really goes for anywhere. If you dig a big hole for livestock, even for cattle, when it rains, it's going to fill up. Now, will there be months where it might dry up? Sure. But if it's got a clay base to it or a sediment or even a rock layer, that's what keeps the water in there. Now, it could be underground, spring fed or something, but the reality is if you go and you scoop up the dirt that's at the bottom of a pond or a lake, it's that. It's all the waste from the plants and the life in the water. Now, can some leaves and dew leaves float into the lake and eventually sink and decompose? Sure, especially near the shoreline. But the waste in the bottom of those systems is this, because there's all the life inside. So when we think about dirt in the sense of, for lack of a better term, aqua soil as opposed to garden soil, that's it. This is aqua soil, okay? Think about it. Think about land dirt and then think about water dirt. So as humans, we like to perceive plants going into dirt like we do when we look at a rose bush or a tree. And things are a little bit different in the aquarium. Now let's talk about aquatic plant roots, because that's a big part of this. And that's really kind of the deal breaker when it comes to all of the terrestrial plant science that is applied to aquatic plants in our hobby. So the roots on aquatic plants are kind of a big deal, okay? And the reason I say that is, and this goes back to the Amazon sword as an example. Amazon swords are big plants. They get really, really big, and they need really long roots to hold themselves down so they don't just float away. Most of these plants seem to know somehow when they're stable, when they're held in place, whether it's with a substrate or a plant weight or a cage like this. In my experience, most of these plants grow a little bit better as far as the upper half of the plant, the stem, the leaves, the foliage, if you will. They grow better when they're held in place. And when you're floating them, a lot of times what you'll find is they put a lot of energy into root growth. And it's not because they're looking for substrate to eat from. It's because they're trying to grow those roots down to attach to anything so they don't drift off. In some systems in nature, if you get drifted downstream and you're a plant, eventually you're going to get flushed out into the ocean. And these plants don't do well in salt water. So if you're in a pond or a lake and you get swept up on the bank because of wind and you're floating, it's hard to grow up on the bank in an inch of water. So these plants grow roots in a different way than land plants. Now, land plants need roots so they don't fall over. Think about how big a tree's roots have to be to hold the tree up, right? It's no different in an aquarium. They're just trying to hold themselves down so they don't float away. Now, do they eat from the roots? They sure do, but these aquarium plants have a superpower that land plants don't have. And that is, this entire plant is a root. Every single part of this plant, the stems, the leaves, the roots, the whole plant is able to uptake nutrients from the water, all of it. The roots can uptake nutrients from the water. The leaves can uptake nutrients from the water. The stems can uptake nutrients from the water. Now, what has been kind of a disservice to the hobby, especially when it comes to creators just kind of doing a little bit of research when it comes to terrestrial plants and deciding to come up with numbers and just make videos on it, is you'll find creators on YouTube and other places on social media that'll tell you that plant right there uses exactly 30% of its nutrient uptake from the leaves and 70% from the roots. That's not true. All aquarium plants that are fully submerged like this can choose and adapt to where they uptake nutrients from. So if you're a plant, you want to grow. You want to grow big and strong and green. Or maybe you're red. You want to grow big and strong and red. Why would you uptake your nutrients down here and use energy to move them all the way up to the very top tip of the leaf? Because if you wanted to, you could just uptake nutrients directly into the stem up here at the top to grow a new leaf, or directly into the top leaf to grow the top leaf. So why would you expend the energy that it takes to move the nutrients all the way up to the top? And the reality is, you don't. Aquarium plants don't work that way unless there's not enough nutrients in the main water column, okay? And that's another part of this that we're going to talk about that is commonly misunderstood in the aquarium hobby, is the water column. But before we get into that, there's another thing you need to know about aquarium plant roots. Pretend this is a bush outside your house. If it's a bush and it's planted in dirt, all the leaves are in the air. It's not going to get food from the air. It has to get food from the dirt. Now, land plants are typically in a dry soil. Out in nature, most land plants are not in mud or water. They're in dry soil. And while they're in dry soil, they use a process to uptake nutrients into the roots called active transport. Okay. And the thing that you need to remember about the word active is that it takes energy, because the roots have to use energy to get nutrients from dry soil. Now, when it rains, the rain falls from the sky and it becomes slightly acidic. When it hits the soil, that slight acidity strips nutrients from the soil. The nutrients gets removed from the soil where they get diluted into the water. And when the water touches your plant's root, the root then is able to use what's called passive uptake of nutrients. And the important thing to know is that when a land plant is getting its nutrients from water, like rainwater or in a hydroponic system, we all know the hydroponic systems grow plants better. The reason for that is passive uptake of nutrients doesn't require the plant to use energy. Why? Because the plant roots in land plants are made out of a semi-permeable cell wall. And what that means is that the water can just pass right through the root into the root. The plant doesn't need to use any energy to get that from the root. Doesn't need to use any energy. So again, just like transporting nutrients in an aquatic plant from the tip of the root all the way to the tip of the plant, why would it do that when it can save energy to use for growth by taking in the nutrients where it needs it? Well, with land plants, if you don't water them, they have to survive on just active transport. And because it uses so much energy, they eventually will perish. It's just how it is. So luckily for us, in an aquarium with a submerged plant, the whole plant is semi-permeable cell wall. So the leaf can take in nutrients using passive transport. The root can take in nutrients using passive transport. The whole plant can take in nutrients from the water without using any energy. So what does that mean for the aquarium hobby? Well, I like aqua soil. I like using aqua soil. It's very black. It looks fancy when the shrimp are on it. But the whole selling point of aqua soil is that it stores nutrients, right? So that your plant can get the nutrients from the aqua soil. But the reality is, as long as there's more nutrients in the water column of your aquarium than there are in the plant, your plant's going to get nutrients from the water, not from the soil. Why? Because getting it from the soil takes energy away from the plant. This is straight up known science. And out in the world and in the scientific community outside of the aquarium niche, this is common knowledge. But because the aquarium hobby, especially on social media, is an echo chamber, people just end up repeating what is essentially misinformation. Sometimes it's a little more innocent, and you could consider it oversimplification, but a lot of it is straight up misinformation. And again, I didn't set out on this journey to disprove anything. I'm just looking to explain why this plant that's simply stuffed into a plastic plant cage can grow just as well like this as it will if it's in gravel or aqua soil. And it's because the whole plant is able to take in nutrients. Now let's talk about the water column, okay? Because that's another important thing. When it comes to how your aquarium plants grow, something to think about with substrate is that your substrate is soaking in water. It doesn't matter what kind of substrate you have, it's soaking in water. So if you have sand, there's water in between each individual piece of sand. If you have gravel, there's water in between each individual piece of gravel. But what you got to think about is that in the main water column, right, which is the water above the substrate, in the instance of this no substrate aquarium, it's the whole aquarium. The water in here is getting circulated constantly by the movement of the livestock. Now, on top of that, obviously, I've got some sponge filters running here that are outputting water up at the surface, which gets shot straight to this front glass, and then the circulation makes it go down. So there's circulation happening on top of the livestock, but the water's getting constantly moved. And if you look into aquaponics or hydroponics, it's moving water over the roots that feeds the plants. Now, can you do it in an aquarium without a filter? Absolutely. I do it in aquariums without filters, without air stones, and it works fine. But when you start using substrate, some things can change. So over here on this side, if I had this pearlweed planted in sand, the water in between the individual pieces of sand is super stagnant. And so the fact that the water is stagnant, which means it's not moving anywhere, it's just sitting there, that's what makes the substrate water column or the substrate level of the water different than the main water column. It's all basically the same water, but what can happen is if this was planted in sand, the waste here, this debris, has a hard time working its way down into sand. And a lot of times that echo chamber will say, well, yeah, you need livestock that'll stir up your sand. If you get trumpet snails, they're going to stir your sand up and they're going to poop in the sand, but then you have 20 million trumpet snails. You could use your hand and kind of, you know, I guess do like this, whatever you want to call that, in the sand and try to get that detritus down in it. But the reality is, for most people, they find that plants don't grow real well in sand, and it's because the roots of the plant are not able to access that debris or mulm or detritus because it's not working its way down into the sand. And then they're removing all this detritus from the top of the sand. Everyone says that's one of the best benefits of the sand is that the detritus sits on top so you can easily take it out. Well, I mean, yeah, this looks like there's poop or dirt or whatever, debris, muck, gunk, whatever you want to call it, is physically all over the bottom of this aquarium. It does have a certain lived-in look to it, right? But the reality is, if I was feverishly gravel vacuuming this every day, which I know there's no gravel, but if I was siphoning out all this detritus, I'm removing the nutrient source from the main water column. So again, if the amount of nutrients outside the plant is greater than the amount of nutrients inside the plant, it's going to use that passive uptake of nutrients, which is the best for the plant because it's got extra energy. It's got all the energy to grow and get color, right? So it's an interesting place that we've gotten ourselves into in the aquarium hobby. Now that's with sand. So the answer to that typically is to stuff root tabs down in there. And of course they want you to put them like every 3 inches in a grid, right? Well, if I told you that this has everything root tabs have, why couldn't you just put this in there? Well, because no one's ever tested it until me, right? So we'll get to that. So when it comes to the water column, gravel, especially round pieces of gravel, there's more gaps in between the rocks to allow some water flow, but the reality is, unless you've got an under gravel filter, there's really not a lot of water flow happening in gravel. With dirt, you typically want to use a sand cap. So there's your sand barrier yet again. And you'll hear a guru here and there telling you that somehow this debris will magically work its way down into the sand to quote unquote replenish the soil. I don't even know what that means, but it's physically not true. That's literal misinformation. It doesn't work that way. Another thing I've heard him say is that the dirt works its way up. I don't even know what that means either, right? But we're not going to get into that. Okay. So when it comes to the water column, that's important for you to understand is that if you're removing all this detritus and you're not adding anything, you could technically have low levels of stuff in the water column and your plants are relying on feeding with their roots. But again, that doesn't mean that the roots are eating substrate. There's water down there and your plant can put all the energy into growth if it uses passive uptake of nutrients from the water within the substrate. So how does that work? Well, it's actually pretty simple. And it's going to involve, unfortunately, some more myth busting. Again, I didn't set out to do all this myth busting. It just kind of worked out this way, right? So let's look at this detritus down here and let's talk about some of the most common myths that exist about mulm or gunk, right? When it comes to this detritus, you'll hear all kinds of stuff. There's people out there that'll say that aquarium waste harbors bacteria that harm your fish. Well, in reality, it's not true. And we'll get into that. I said this before, but the most common thing you'll hear people use as a phrase to kind of describe this gunk or debris is excess nutrients. Well, guess what? The nutrients inside of this solid waste are not in the water column until they get broken down. So that's not excess if it's contained within that solid waste. What's excess is things like liquid fertilizer, and we'll get into that. So let's talk about the lab test, okay? When it comes to the lab test, one of the biggest reasons that everyone likes to parrot in the echo chamber for why they need to use dirt, which again, I'm not against dirt, it looks awesome, right? But when it comes to social media, everyone's got to be a teacher and everyone has to explain everything. Here I am doing it, right? So there's no testing that's ever been done in human history, and tell me, on home aquarium waste. So nobody had any references to cite when it comes to their excuse for needing to put garden soil into an aquarium that's full of plants that don't get their nutrients from soil. The way these plants eat using water, you would be better off soaking your tank water in a bucket of dirt so that you don't have to put inches of dirt and sand into your aquarium. Let bacteria and water break down the nutrients out of that dirt and then use that dirt, or excuse me, then we'll let the nutrients break down out of the dirt into the water in a bucket and then use that bucket water for your aquarium. And then you don't need to put dirt in your aquarium. I mean, that scientifically would work, right? It's very crazy. So when it comes to the testing here, I'm just going to quickly read off all of the things that are contained in this home aquarium detritus. I hope you're prepared. Nitrogen, carbon, phosphorus. We got potassium, calcium, magnesium, sulfur, sodium, iron, manganese, zinc, copper. It's crazy, right? Now, the levels that are in the home aquarium waste is what really is going to shock you. So we're going to talk about that next when it comes to aquarium waste and exactly how much of what is in it, okay? So for the dirt crowd, and I'm not saying that like it's a bad thing, I'm saying it because it's true. The most common thing they'll reference is a book called The Ecology of the Planted Aquarium. And in that book, a claim is made that the reason you would use garden soil is because it's rich in iron and other substrate types like gravel, which gravel is a rock. Of course, it's not going to feed your plants. So what's actually meant by that is gunk, detritus, mulm, whatever you want to call it, does not have sufficient iron. But no testing results were provided. And as far as we can assume, testing was never done, because if testing was done of the actual detritus, it would be in the book, right? And now that you know some of this, you'll definitely notice that within the echo chamber of the aquarium hobby, they like to kind of bypass this gunk at the bottom of the aquarium. They'll love to talk about gravel as if rocks have anything to do with how your plants eat. So they like to focus on the gravel, but they never talk about the aquarium waste. And if they do, again, remember, they call it excess nitrogen. So let's talk about that nitrogen. You'll see I've got a bottle of Aquarium Co-op here, conveniently at the bottom of this aquarium. I've got some Easy Green. The test results of my home aquarium waste showed that it's 2.57% nitrogen on a dry basis. Now, what does that mean? It means that not including the water. So when I siphoned out my aquarium waste to send it off to the lab, it contained some tank water in there as well. So we're specifically talking about just the waste here. That's something that people like to question when I talk about these test results. Are you sure your water doesn't have ammonia in it? This is the dry testing of that gunk, 2.57%. So what's interesting is the amount of nitrogen uh, as we see the Aquarium Co-op Easy Green, the percentage that's in that fertilizer. It's very similar to the percentage that's in the aquarium waste, believe it or not. So I'm not going to reach in there and turn that bottle to the side. I guess I can, so we can physically see it, so that you don't think I'm just making this up. But we'll spin this bottom here, and then I'll get us zoomed in on it. But again, I did not design this adventure to myth bust liquid fertilizer. As an aquarist, I wanted to know how much nitrogen was actually in that gunk, because no one talks about it. Do you see what I see? It's 2.6%. Well, wait a second. If that's 2.6% nitrogen and all of this gunk and debris at the bottom of this aquarium happens to also have nitrogen, and it just conveniently is 2.57%, which we could easily round to 2.6%, which one is excess nutrients? Which one is excess nitrogen or nitrate? It's crazy, right? Now, back to how I'm holding these plants down. You'll see those plant weights in here holding these crypts and stuff down. There's some Hygrophila chai there. But you see what I mean? I just take a little bitty piece and just lightly clamp it on the plant. And that's usually enough to hold it in place. And they just feed right from the water column. It's an amazing thing. And it's probably the future of the planet aquarium. Very interesting stuff. So let's get back to this Aquarium Co-op Easy Green here. So we've got 2.6% nitrate in Easy Green, 2.57% nitrogen in aquarium gunk, oddly enough. Now, what I find interesting is, first off, the creator of Easy Green, and this is easily available if you want to look at the videos on Easy Green, he recommends that customers like myself, I bought it, they didn't give it to me for free. So he recommends that I test my water column, and in the water column, I need to have between 20 and 40 parts per million of nitrogen from Easy Green. He makes sure to say from Easy Green, but how do you really know if it's from Easy Green or not? You don't. So if he's telling me that I need to have 20 to 40 parts per million in here, I want you to think about the fact that however much detritus is in here at 2.6% based on volume, none of that is going to show up on the test because it's not in the water column. It's being safely contained in that solid waste. But if I dose that Easy Green to get my water column up to 20 to 40 parts per million, all of that nitrogen is now available for algae. The algae can't eat it while it's contained in safe storage in the gunk. But if you're jacking up the nitrogen to 20 to 40 parts per million, according to the creator of this product, that's what you should do. You're creating a buffet, a Las Vegas style buffet of excess nutrients. Now, my second point here is if your plants are uptaking nutrients from your aquarium, you're probably going to show 0 on the test. That's actually one of the huge reasons that especially new aquarists, but most aquarists will say, I don't show any nitrates on my test kit, so I don't need to do water changes because I've got plants. For whatever reason, the hobby has blinders on when it comes to water quality, which is insane because that's what these glass boxes are full of. They're full of water. Now, the idea of never changing your water because you don't show nitrates on a test kit, luckily, that's somewhat new when you look at how long the hobby's been around. I don't think that it's going to remain a thing forever. I think that although there's lots of disadvantages to AI, one of the great advantages of AI is fact checking. And eventually, I do believe YouTube and other social media, like we see on X, formerly known as Twitter, will have both community notes and AI fact checking that's going to be able to reference actual science. And once real science starts getting brought into the aquatic hobby, right, those misappropriations and misinformation aren't going to fly anymore. So unfortunately, again, I didn't set out to make it this way, but I've kind of stumbled on the future of fish keeping here. Now, Why would you want to have 20 to 40 parts per million excess nutrients in your aquarium? And then on top of that, where you've got the nitrates safely stored down here in the waste, you siphon that out and feed it to your house plants? I mean, it's almost maddening, right? Which I didn't mention it yet, but those tiny little yellow shrimp, those little tiny precious babies, those are lemon yellow amano shrimp. And my two YouTube channels that focus on shrimp breeding are the first channels on social media to ever document the, I guess, first colony of lemon yellow amano shrimp that's raised in a home aquarium. I'm not the smartest guy in the world, and I put very little effort into breeding these yellow shrimp. There's probably easily like 150, 200 of them in here at the current time. You see how small they are compared to those blue Neocaridina shrimp in there. But yeah, those tiny yellow shrimp, those are not yellow Neos. Those are Amano shrimp. So nitrogen and the wacky idea that you need to have 20 parts per million nitrogen in your water column when you've most likely got shrimp and snails and fish and detritus. It's really nonsensical when you think about it, but unfortunately, the echo chamber is a fortress in this hobby. So we could go down the list here and compare exactly what's in aquarium waste to what's on the label for this easy green, but the reality remains that you, the viewer at home on your couch, I assume and hope that you're watching this on a big screen TV. You've got to send off your own aquarium waste to know for sure what's in yours. Just because mine says 2.5%, 2.57 to be exact, of nitrogen as a dry nutrient in the aquarium waste dry form. Just because mine says 2.57, yours might be a little higher than that. It might be a little lower than that. But the reality is, once you know what it is, well, you can kind of change your perspective, your perception of how much nitrogen or nitrate you think you need to have floating around in the water for algae to use. Now, this tank I've only had set up for, I think about a week now, so it's kind of hard to tell in the video, I think, but it's in that stage where it's kind of cloudy with infusoria and stuff because it's fairly new. But all of the plants that are in here came out of the aquarium next door. So all of these plants were grown without any substrate. And you can see on the crypts there, the roots just chilling in the water column. So if your test kit shows 40 parts per million, that is the excess nitrogen, not what's contained in the detritus. And again, just like no matter what kind of substrate you have, it doesn't matter because your plants want to use passive uptake and not use energy to get nutrients from the substrate. Well, when it comes to fertilizer, no matter what kind of fertilizer you use, if you have detritus in your aquarium, you're removing it in some case. Now, there's tons of people that never remove the detritus. You know, and all of that is pretty nuanced. Like if I was having huge algae outbreaks in this tank, I would definitely want to move all the plants to one side and take out a bunch of detritus and then move all the plants back. And luckily with no substrates, really, I mean, that's like a 10-second job to put my hand down there and just move all the plants over. Now on the flip side, if this was, let's say this is a 20-gallon, which it is, and all I had in here was a single bed of fish, no snails, no shrimp, no other fish. Well, with this many plants in here, there's a good chance I'm not going to have enough nitrogen to feed all of the plants. So in that case, I may want to add liquid fertilizer. So again, there's a time and place for everything. And in some cases, you're going to use multiple things to feed your plants. But the reality is, if you're looking at your plants and you're not seeing yellow leaves or pinholes, it doesn't matter what the guy on YouTube says, your plants are fine. You don't need to add anything. Why would you add anything? Not only that, but why would you supercharge your water column for algae by upping the parts per million of nitrate to crazy levels when your plants are doing just fine using the detritus, right? Now, something that's kind of crazy is some of these fertilizers have a bunch of extra stuff in it and some don't. One of the common reasons people say that they would use a fertilizer like an all-in-one fertilizer, like Easy Green here, is because it has a little bit of everything, but when you look at this label here, you've got the 2.6% nitrogen, but when it comes to the phosphate, you got 0.46, right? Now, when I look at my test, my phosphate level is 0.416. So we've got phosphorus. Now, when we look at the potassium, I've got 0.253, okay? When you look at the potassium, which is listed as soluble potash on the Aquarium Co-op, 9.2%. My plants are doing just fine at 0.2, and that's got 9.2. And what boggles my mind is the creator of this fertilizer in his own video. The creator of this fertilizer makes the claim that the reason that it has so much of that potassium is for slow growing plants like Java fern and Anubias. I don't know how that makes sense that you would put that much of it in there for plants that grow extremely slow. Maybe you at home can figure that one out, but I cannot find a logical reason for that. Doesn't make a lot of sense. But what does hair algae love? Well, 20 to 40 parts per million nitrate in the water column and huge amounts of potassium. And what's interesting, and this is, I think, a final piece I'll do on the Easy Green here, and I'm just using Easy Green as an example. Just like with the substrate, I have no reason to try to talk down about products. I'm simply comparing the scientific data and the numbers. So I'm not saying that you shouldn't use Easy Green. I bought it. I mean, you definitely should try anything. Try it all and see what works best for you at home. But what's interesting about the Easy Green here, again, the instructions from the creator of the product says that you need that 20 to 40 parts per million. So what's interesting about that is if I take 10 gallons, this is 1 milliliter per 10 gallons. If I take a 10-gallon aquarium and I fill it up with tap water and it has 0 nitrogen, the creator of this product has told me in his own instructions, his customers, that I need to add this product until my test kit shows at least 20 parts per million. Yet on the label, dose once a week for low light, twice a week for medium light, 1 milliliter per 10 gallons. If you put 1 milliliter of this product in a 10-gallon aquarium with water that has no nitrogen, in order to get it to 20 parts per million, you're actually going to need, we'll use squirts as an example. These used to come with the Easy Squirt cap on it. So 1 squirt or 1 milliliter for 10 gallons. You would likely need about 7 squirts. Now that's based on the number on the label, the 2.6%. When you do the math, it puts you at 7 squirts to get to 20 parts per million. Anyone that's had a planted aquarium that does not use any kind of additional fertilizers, your test kit in most cases is going to be 0 for nitrate. So it's going to take you 7 squirts in 10 gallons. That's just 10 gallons. So as you can imagine, you're going to go through this stuff pretty quick. But the most important part is 9.2% of that potassium times 7. So again, I'm not saying that it's wrong. I'm looking at the physical numbers, and what the numbers say is that it's not 1 squirt per 10 gallons if you're at 0 nitrate. It's 7. So if you do the math on that and you come up with a different number, by all means, make a video on it. I would love to watch it. So it's an amazing thing when it comes to the echo chamber and the aquarium hobby and the numbers that kind of get chosen for things. And is there really even a reason that you need to maintain 20 to 40 parts per million of nitrate in an aquarium? That's the definition of excess nitrates. Again, the nitrates in the waste there, the debris, the nitrates there are safely contained inside the solid waste. They're not available to the plants until it gets broken down into the water column, unless it's physically touching or is right up next to the plant root. So this boggles my mind. And again, at this point in my, I guess my aquarist life cycle, I'm just trying to figure out why these plants grow so good just weighed down in the aquarium. That's all I'm trying to figure out. I'm not on a quest to get you at home to take the substrate out of your aquarium. I got 1, 2, 3, 4 aquariums right above here that have aqua soil in them. So, I mean, again, I'm not telling you at home what to do. I'm showing you what's physically happening in my aquarium, and I'm looking at the data and I'm trying to draw a conclusion of why it's happening. So it's an interesting thing. Now, when it comes to this aquarium waste, this gunk that's in the bottom of our aquariums, it's kind of a fluffy brown stuff in some cases. You'll see in the echo chamber that people love to claim that having excess amounts of this aquarium waste is going to be harmful to your livestock. So I want to talk about that real quick. When it comes to bacteria, there's some specific phrases that you'll often hear parroted in this hobby. One of them is surface area for beneficial bacteria. It doesn't matter what you're talking about, whether it's a sponge filter or substrate. That phrase has to be included in the discussion. And what I think is kind of hilarious about that is it's true that there's bacteria that live in your substrate and there's bacteria that live in your sponge filter. But what kind of bacteria lives where? And which types are harmful to your livestock? So let's get into that here. Your aquarium waste is broken down by what's called decomposer bacteria. Decomposer bacteria decompose things. They break down non-living organic waste. So your decomposers, a lot of times people think of it as just seed shrimp or scuds or even dwarf shrimp or snails. And they are, but on a microscopic level, you've got decomposer bacteria. And that bacteria lives in and on the aquarium waste. Some of it lives in the gut of your shrimp or your fish or your snails, and it starts to break down the food before it even makes its way completely out of the livestock. Once it gets pooped out into the bottom of the aquarium, now it exists in the bottom of your aquarium, in and on the solid waste. Now that waste gets broken down into all of those things that I mentioned previously in the water column, not just nitrate, all of those things. So when this bacteria breaks it down, you could say that it's a beneficial bacteria in relation to the nitrogen cycle. But in reality, your fish can also produce ammonia from their gills that gets used in the nitrogen cycle. The bacteria that change ammonia to nitrite and nitrite to nitrate, they typically do not want to live in your substrate. Now, they may live towards the surface, but they want to live in your filter media. And the reason for that is because there's flow. Just like the plant's roots and the plant's leaves, they want flow because flow brings new nutrients for the plant to eat. And so, being that those bacteria, they want to eat that ammonia or nitrite in the water column, they want to be where there's flow. So they prefer to live in filter media or on the top layer of the substrate. Now, more importantly, let's talk about one of the common misconceptions that gets brought up about having excess waste or gunk or debris in the bottom of your aquarium. And that's that your fish are going to get pathogens. They're going to get pathogenic bacteria from there being excess waste. Now, it's true that there's bad bacteria in poop on land. Insert what kind of animal or life form's poop you want to visualize. But if you get poop bacteria of certain kinds in your eye, it could make your eye red for a couple days. If you were to try to consume poop, there's bacterias and different things in the poop that can harm you, right? But in our aquariums, when it comes to those pathogens, they're different than those decomposer bacteria. The decomposer bacteria that are on detritus is a saprophyte. They're kind of like, think of them like a cleanup crew. So pathogenic bacteria, they prey on living things. They're not going to be breaking down the waste in the bottom of your aquarium. And if a fish swims by, they say, oh, I'd rather have that. And they jump onto the fish. Pathogenic or predatory bacteria prefer the water column to find hosts. They're not just, they're not a byproduct of having excess waste in your aquarium. Now, what is a byproduct, and this tank is not exactly an example of it, but the water is cloudy because it's newly set up and it's got a little bit of a bloom happening with bacteria and infusoria. So it's, in that way, it's kind of a good example to use. But if you have too much aquarium waste in your aquarium for too long, what you may notice is your aquarium water start to turn kind of a yellowish color, almost like tannins from wood or leaves or botanicals. So let's talk about that, the tannin effect. High detritus levels might tint that water. And technically, this is kind of a feature. Now, I personally don't like the look of yellowish water, whether it's from leaves or any kind of botanical seed pods or something, whether it's from wood. I don't personally like that look. Again, just like, you know, I'm not trying to talk you out of using substrate. I don't care what you do. And I use tanks with substrate and without substrate. That's one of the reasons that I don't like wood, is because a lot of types of wood. Now, I've had wood in the past of certain kinds, like you can get, I think it's Mopani wood. It sinks right away. But it can, you know, it can yellow up your water a little bit. Spider wood, not as much. Choya wood, not a lot of tannins there, but they all have a little bit of yellowing to them. Now, it's not bad for your fish. I think a lot of times we overstate how good stuff is, and, you know, we'll say that something that can be good for your fish in some instances gets kind of exaggerated into, you know, something that you have to do. And that's not what I'm trying to say here. But what I'm getting at is the yellow from excess waste in your aquarium is not necessarily a bad thing. Now, again, I don't like yellow aquarium water, so that's personally one of two things that I usually use. Actually, technically one of three things I usually use to determine if I need to remove some of the waste. One of the things that I use is the condition of the plants. So I like to look at the new growth on my plants. And if the new growth on my plants is telling me that I have too much nutrients in the water, I'll remove some nutrients. But typically the way you'll know is you'll start to grow algae. And you'll notice that a lot of times on your plants. Now, you might have a powder algae on the back of your aquarium glass or on the sides of the aquarium glass that doesn't really bother you. Maybe you get some powder algae on the front that you have to clean off to see in. It's a little bit of a nuisance. But obviously, for most people, we don't want to have giant masses of hair algae. We don't want that powdered algae to start covering all the leaves of our plants so that the plants stop growing as good because they're getting blocked from the light by that powdered algae. Most people are not in love with blackbeard algae or staghorn algae, but these are natural processes of the aquarium that a lot of times just happen as part of the aquarium cycle. It'll have a staghorn phase. It can have a hair algae phase. It's not the end of the world. But if in your hair algae phase or any of the phases of algae, you're constantly adding liquid fertilizer or root tabs to see 20 parts per million on a test kit, you're really feeding a lot of that. It's just part of it. But now, looking at the growth of the plants can tell me when it's time. Seeing algae can tell me when it's time. Another way that I know when it's time is if the water starts to get a yellow tint to it, or when I look into it, if there's a bunch of debris in the water, which I guess from this angle, we can't see it as much. In the beginning of the video, you could really kind of see a lot of the debris in the water. To me, that's a sign I need to clean my sponge filters in a lot of cases. And that's a way of removing detritus, because there's going to be detritus, mulm, whatever you want to call it, gunk, waste, and those sponges and all that little stuff that you see floating around. Those fine sponge filters, their job is to filter out those tiny little dots in the water column. So that's another way I can tell when it's time to remove detritus. But what I don't do is I don't base it on how it looks. And like anyone else, when I first started to keep aquariums this way, and for most people, that is with quarantine tanks, or if you have monster fish and you don't want to deal with them constantly rearranging or shaping your substrate, or maybe you breed shrimp. If you paint the bottom of the aquarium black, it really gives a high contrast to that aquarium waste. It's not as bad if it's just a reflective bottom to the aquarium, but you can still see it loud and proud. It's not like gravel where it kind of gets hidden, at least for a couple years, or depending on your stocking load, a couple months possibly. But eventually, if you're building it up faster than it's being broken down by those decomposer bacteria, eventually you're going to see some excess detritus peeking up above that gravel line. And eventually you're going to end up with an inch of detritus above your gravel. And so again, I've seen people make the claim that their fish swam through it and then they got a fungal infection, and it's because of the detritus. It's usually if a fish has a low enough immune system to get a fungal infection or to get a bacterial infection, a lot of times fish can chase each other around and they can kind of peck at each other, or they might bump into some sharp hardscape or something and get a sore that gets infected. I mean, but typically your fish are covered in a slime coat, so they're not just going to randomly pick up a bacteria and get sick off of it. And you may not already know this, but there's tons of bad bacteria or pathogenic bacteria that's common in an aquarium and you don't see it until it becomes a problem. And usually it becomes a problem because your fish is new and stressed and just got shipped from who knows where to the pet store. And just when it started to get used to the pet store's aquarium, you buy it, you take it home, it's got to transition again. But you know, there's many instances of rhyme and reason as to why your fish's immune system could get low, but that's usually when you see that sort of thing. They've evolved to have that slime coat specifically to protect them from those pathogens and molds and fungus that's in their natural environment. And so the idea that our aquariums need to be sterile in order to be healthy is not exactly true. And the reason why I'm saying that excess detritus can be a good thing at times is the bacteria that break down this gunk reproduce like 100 times faster than the bacteria that could possibly be bad in most cases. But where it can kind of get bad is they also reproduce like 100 times faster than the bacteria that do the nitrogen cycle, for instance. So there's always a balance to things. And these aquarium wastes or gunk at the bottom of your aquarium, humic substances, humic, not human, humic substances, and organic acids are a natural product of this breakdown process. And it basically mimics those natural blackwater environments that you see people buying leaves or collecting leaves to recreate, or using tannins from wood or botanicals. And this basically buffers your aquarium and provides a more natural immune boost for your fish, believe it or not. Now, again, as I mentioned earlier, just because something can be good doesn't mean it's mandatory. And for me personally, I don't like yellow tinted water. That's just a personal deal. So it's interesting to think about the actual products of the aquarium waste, what's inside and what's not, and whether or not it's harmful. Because if you understand that there's a pretty good chance that unless it's just complete excess waste and you've got so much nutrients being broken down into your water column at any given time because of how much waste you have, and you don't have enough plants to keep up, then yeah, technically it can start to feed algae. You can have an algae outbreak. Eventually the algae might overtake your plants and it can be a bad thing. So it's very interesting when you kind of look at this fish poop, snail poop, shrimp poop, the waste in our aquariums, and what we've done with it and how we've talked about it over the history of the aquarium hobby. And it's really interesting, at least to me, to think about how that is going to change over the next 5 years or 10 years or 20 years, as within the hobby, we make not only great advancements with science, but also something to think about is more and more people are putting houseplants into their aquarium than ever before and just submerging the roots into the aquarium. And for those people, those roots feeding from the water column in basically a hydroponic setup, or those roots are uptaking the nutrients directly from the water. And so the answer is right in front of you. And so I think over time, you know, I don't necessarily think that a poop covered glass bottom aquarium like this is going to be the new normal. But I think our understanding and the way that we speak about aquatic plants eventually is going to have to change. And so I just think that the easiest way for it to make sense to you as an aquarist is to get your waste tested at a soil and wastewater analysis lab. They specialize in it. They will know exactly how to handle the aquarium waste. And more importantly, at the end of the day, you'll know exactly what you have and what you don't have, because the nitrogen that's sitting in that aquarium waste is not going to show up on a test kit. So hopefully you enjoyed the video. I appreciate you checking it out. As always, make sure you look at the playlist on the channel, and we'll see you in the next one.